Right, we're going to look at gradient today, okay? And hopefully you've heard of gradient before, you've come across it not in everyday life as such, but you've seen it from time to time. And it's basically to do with the steepness of something, how steep a line is, or how steep a slope is, how steep a road is, whatever it is, they all tie in under the bracket of gradient. We're going to actually calculate the gradient of certain lines, certain slopes, and so on and so forth. Right, a lot of people think it's to do with angles. It's not really. It's to do with the ratio between the horizontal distance covered compared to the vertical distance covered. And I know that's maybe a little bit confusing thinking about ratios, but at the end of the day, a ratio is just a division. And that's actually where our formula comes from. But we're going to look at a couple of examples first of all to kind of describe what we mean by gradient. Okay, so if I show you three lines first of all, got this line here, and a final line like so. Right, what we can hopefully see from these three lines is that the gradient is increasing as we go from left to right. This first one here actually has a very, very low gradient. It's almost flat. But this last one, okay, is almost vertical, has a very, very high gradient, okay? And that's actually determined, as we look at it a little bit further, it's determined by two dimensions, okay? And it's not anything in terms of the length of the line. It's to do with these two, what we call the vertical distance and the horizontal distance, okay? And they're the two lengths, the two dimensions that we actually want to use in our formula to find the gradient of these different lines, okay? And as you can see, as we go along these different lines, the difference here, the vertical gradient in this first one is much smaller than that of the horizontal distance. In the second one, the vertical and the horizontal are actually virtually the same. And in this last one, you can see that the vertical distance traveled by that line is much greater than the horizontal distance, okay? And that's where our kind of actual formula comes from. And if we're going to try and find gradient, in this respect at least, and there are different ways of doing it, and it may involve different problems, but gradient in a general sense is the vertical distance of a line divided by the horizontal distance. Okay, so there's a little bit of division in this, but what actually ends up being is pretty much just a fraction. Okay, so there's a few things involved in terms of fractions, but gradient generally is vertical distance divided by horizontal distance. So what we need actual dimensions. Okay, so if I redraw these lines, okay, and what we're going to want from each of these is we're going to want, as I say, that horizontal distance and that vertical distance. And we can use both of them and combine the two of them to actually find our gradient. Okay, what I mean by a horizontal distance is basically from the start to the finish of that line, how far we have travelled in that horizontal direction, and vice versa, similar idea with the vertical distance. How much of a kind of an increase in height have we gained across that line, okay? So we'd have two dimensions here. We'd have something along the lines of, let's say this is 12 centimeters, and let's say this is 8 centimeters, okay? And as long as we have these two dimensions, then we can work out our gradient, just using that exact same formula as above. Gradient will equal the vertical distance, which is this length here, okay, divided by the horizontal distance, okay? So divided by 12. As long as it's a division, you can set it up as a division. You can actually do that as a sum, okay? Generally, when we're dealing with gradients, we're quite happy to just leave it in terms of a fraction, okay? However, obviously with fractions like this, we want to simplify where possible. 8 and 12 actually both divide by 4, okay? So we can simplify this to 2/3, okay? Right, in some situations, we don't want to necessarily leave it as a fraction. We can change it. And we know from past experience, if we have fractions, we can rewrite them as decimals, and we can also rewrite them as percentages. You may have seen percentages actually written in terms of the gradient of a road. If any of you have been out and about up in the hills in Scotland or anywhere, there's often signs that tell us about the gradient of the road. Some gradients can be too great for certain vehicles, okay, so there's road signs at the side of the road that will indicate the gradient of said road, but it will do so with a percentage, okay? But if we have a fraction, we can rewrite it as a decimal and as a percentage. I'll change these in a second so that we can see that, but let's just get these examples done first of all, okay? So this second one here, okay, we've got our horizontal and our vertical. Let's say this is 24 meters, and let's say this is 18 meters, okay? Not quite to scale, but the gradient is still done in exactly the same way. It's going to be our vertical distance, which is 18, divided by our horizontal distance, which is 24, okay? So you can stick that in a calculator. That would give you it as a decimal, okay? But generally these are going to be in terms of non-calculator questions, in which case we want to just take the fraction that we have and we want to simplify it down. 18 and 24 both divide by 6, okay? There's 3 of them in 18 and there's 4 of them in 24, okay? 3 over 24. We could leave it like that. As I say, we could change it to a decimal, we could change it to percentage, depending on how the question is given to us or what the question is looking for, but that is fine. That's all we're really looking for in terms of an answer. So for this last one, which we can hopefully see is the most steep of them all, okay, we still need a horizontal and a vertical. Let's say this is 12, where's my pen gone? 12 centimeters, and let's say this one is 40 centimeters. Okay, our gradient, still in exactly the same one we've done the previous ones, is going to equal the vertical, which is 40, divided by the horizontal, which is 12. Okay, right, we've got top-heavy fraction just now. Nothing wrong with that, don't worry about it. And we're going to simplify it down. It's still going to be fine as it is. Okay, these both divide by 4 again, so we get 10 over 3. Now that's fine. Nothing wrong with that question, okay, with that answer. 10 over 3 is fine as a gradient, but we can see, hopefully, because it's a top-heavy fraction, it might be better as a decimal. It might be better to understand if it was. Right, but if we were comparing, it probably is better to write it as a decimal. Without these diagrams, if I was just looking at these numbers, it might be difficult to see which of these is the biggest. So it's often better to write it in terms of a decimal so that we can see that. All we're doing by writing it as a decimal is we're just doing the sum that the fraction that has for us. This is just 2 divided by 3. 2 divided by 3, if we put it into a calculator, or we could do a sum, is going to work out as 0.66666. 3 divided by 4 in the same way. Okay, you could put it in a calculator, okay, or you can do it as a sum, would be 0.75. And then 10 divided by 3, in exactly the same way, would be 3.333. Okay, hopefully you can see from these 3 numbers that the biggest one is clearly 3.333. And what that tells us is that the third line here is the steepest. We can see that from the diagram, but we're not always going to have a diagram. And then 0.75 is obviously in between these 2 numbers, so the steepness of that is somewhere in between. Okay, so it's often better to write these as decimals in order to compare them. And sometimes we might want to write them as percentages so that we can do a different application for them. As I say, rule signs are often written in terms of percentages, so it might be better to do that.